triangle situation with the ones we've been doing? I know it's not exactly the same one, but so we've got a 30-degree angle here. And that's not letting me erase it. That's weird. Okay, and our side lengths are 4 and 4. Oh, they're the same length. Or if this one were bigger, we're going to have the same issue. So this is our last little rule right here, where if A is greater than or equal to C, then gamma is acute and only one triangle will exist. So I realized when we did this problem, we had an acute gamma, but we also have an obtuse gamma. So we have one that's obtuse and one that's acute. The first one we found was acute. But in this situation, gamma is always going to be acute in this angle right here. In fact, in this particular problem, if these two sides are the same, then this is an isosceles triangle. So this would also be 30, which means that this angle would be, let's see, 60, 120. And then we could find this side by using law of sine. So we can just do sine of 120. Oh, I did it in the opposite order. That's okay. Sine of 120 over, oh, that would be side B, wouldn't it? Equals sine of 30 over 4. And it doesn't matter if we're using alpha or gamma because they're both the same. So then that would give us, since I set this up with my variable on the bottom this time, it's going to look a little different. We haven't done one this way, so I think this is probably a good process. I'm actually going to write out my cross multiplying really fast. I don't need to write sine twice. So sine 30 equals 4 sine 120. So then we're going to just divide. So a b equals 4 sine 120 divided by sine 30. It does end up just working the same, but do you see how I used the reciprocal of the formula I was using? It's the same formula. That's why we said that at the beginning. It doesn't matter which way you do it. Okay, throw that in a calculator. What do you get? Yeah. Well, I know. Lauren, we want you back, even if you have siblings that are noisy.